Hi, everyone, and welcome to our session on evaluating and improving generative AI applications. My name is Bistolnitz. I'm a principal advocate at Microsoft, and I'm here with my colleague, Daniel.
Hello, everyone. Happy to be here with all of you. My name is Daniel. I'm a principal data scientist at Microsoft, and I look forward to demoing some of our latest technologies in this session.
So, Daniel, can you tell us what you're going to be building today?
Sure. Today, we're going to imagine that we were hired by an outdoor equipment store to build a chatbot application. The basic idea is that the user asks questions about the store's products, and the chatbot answers those questions with helpful information.
And how are you going to be building that application?
We're going to be using a technique called Retrieval-Augmented Generation, or RAG. This technique augments ChatGPT with our own data by simply injecting that data into the prompt. But more importantly, we're going to see a systematic method to test and improve our application using metrics.
That's super cool. Every time I write an LLM application, I feel like there's just so many choices that go into it. I think that having a systematic way to decide which choices work and which ones don't is super important.
Exactly. And this technique isn't just for chatbots. It's a great way to improve any generative AI application.
Cool. And so can people follow along with the code?
Sure. Here's a repo with the final code. So just open it up and follow along.
Great. I think we're ready to look at this demo, don't you think?
Yeah, let's do it. Okay. We're going to start with an empty project, and we're going to add the files we need as we go. As you can see, I have just a few basics in this project. I have a conda environment file with all the packages I need, and I've already created and activated the conda environment. I also have a .env file with some secrets that are specific to my Azure account, and I have an empty source folder where I'll be adding all of my code. In addition, I installed the PromptFlow extension in VS Code.
Okay, so you mentioned you're going to use your Azure account. Is there any other setup that you did on Azure ahead of time?
Actually, yes, I did create 3 resources ahead of time on Azure. An Azure OpenAI resource with 3 deployments, a GPT-4, a GPT 3.5 Turbo, and an embedding deployment, and a cognitive search resource that will hold our proprietary data, and an Azure ML resource that will allow us to do the runs and evaluations. I also created a couple of connections to the search and OpenAI resources so my prompt flows can access them.
Okay, cool. So are we ready to look at the retrieval-augmented generation code?
Well, before we look at the code, it's helpful to show a quick refresher for the RAG pattern. In this pattern, we create a cognitive search index ahead of time, and we add our company's proprietary data to it. Then, when the user types a question in the chat app, that question is compared to the documents in the index, and a few of those documents are returned as the best match. Then we construct a query that includes both the user question and the matched documents, and we ask the LLM to answer the user's question using those documents provided. The LLM answers our question, and we'll return that answer to the user.
Yeah, that makes it clear. I've noticed that the RAG pattern has become super popular recently. But back in the days, I remember fine-tuning models whenever I wanted to extend them with new data. But I don't really see that being done quite as often these days, don't you think?
Yeah, that's right. Because now that we have these very large language models, this pattern is actually more effective at using our data in the answer. It's also much cheaper and easier to implement than a full fine tune.
That's great. So are we ready to look at the code now?
We're ready. We'll start by copy pasting our data files. As you can see, each file contains information about a product from our outdoor equipment store. So next, we'll copy over the code where we create a cognitive search index and upload our data files to it. So this initialize function contains the main logic, and the load and split documents function is where we load and pre-process our data. So let's take a look. As you can see, we first load our data, and then we split it into chunks of 5,000 characters with 100 characters of overlap. Then we extract the title of each document and add that to the top of the chunk. And we create a list containing information for each chunk. a unique ID, the content of the chunk, and the name of the source files where the chunk came from.
So Daniel, why do we have to split our data?
A good question. Our LLM has a context size of 4,096 tokens. And in those 4,096 tokens, we need to accommodate, obviously, the user's question, the chat history, the system prompt, and the product information that we are retrieving from cognitive search. In our scenario, the product information files contain a lot of information, and we typically don't need all of that information to answer a single question. And some questions require content from multiple products to provide a good answer. So smaller chunks allow us to pull in content for more products. And also, in general, tokens cost money and time. The more I transmit, the longer my request takes and the more money I'm spending. So saving tokens is generally a good idea.
That makes sense. And why do we need our data to overlap?
Well, that's just because we want to make sure that we can capture any ideas that span two chunks. Okay, next we embed each of the chunks using an embedding model from OpenAI.
Can you explain what an embedding is?
Yes, an embedding is just a sequence of numbers or a vector in a high-dimensional space that represents the meaning of our text.
And why are we using an embedding here?
We embed each chunk because later we'll be doing a vector search on this data, meaning our cognitive search will compare a vector representing the user's question with each of the data vectors that we're creating here and then return the closest matches. By using vector search, we can search based on the general ideas or meaning of our text, not just keywords. Okay, next we define the search index and we upload our data to it. We can now run this file, and if all goes well, a search index will be created on Azure. The name of our index should be RAG PromptFlow index. So let's check our cognitive search resource, and here's our index. We can click on the search button and see all the data we added to it. We have 20 data files, and you can see that we split those data files into 57 chunks.
That's awesome. So now we have a vector index with our data. What's that fields tab over there?
The fields tab shows the fields of our index, which are an ID, content, and source file, just as you saw in the code.
Great. Can you show us the RAG diagram again, just so that we can all understand everything that you've shown us so far and what's coming up next?
Sure. So far, we've added our proprietary data to an index in our cognitive search resource. Next, we're going to create the code that searches the index for documents related to the user's question. Then we'll create a query including the user's question and those documents, and we'll return an answer to the user. We're going to build this part of the code using PromptFlow, which is a tool that my team has developed.
So why should we use a special tool for this? Can't we just write the code in a Python file or notebook as usual?
Well, you could, of course. The main advantage of creating a flow for this code using PromptFlow is that later we can easily evaluate our logic based on any metrics we like. We can measure the quality of our app using a batch of tests, make some changes to the code, then measure the quality again and iterate on this process over and over. This makes it much easier to quantify how much our changes are improving the app. In addition, PromptFlow will help me manage my secrets securely. It allows me to send batch jobs to the cloud, and it allows me to deploy in the cloud.
Okay, I'm convinced. So how are we going to build this flow?
I'll create a new directory for my flow, which I'll call RagFlow. And then I'll create a new chat flow. I'll go to the visual editor and I'll pick a connection and deployment here. At this point, I have a basic flow that I can use in chatbot type scenarios. You can see the graph for this flow, which is very simple, which is just a single node. The flow is defined in this flow.dat.yaml file, which you can see defines the single node in the graph. 2 inputs and 1 output. The node in the flow is of type LLM, which means that it sends a prompt to an LLM. The prompt template is defined in the chat Ginger file here, and it's just a generic prompt that passes in the chat history and the user's question. So I'll run this flow, and let's choose to run it in interactive mode. And we can now chat with this chatbot. Let's ask, which two-person tent do you recommend? Of course, our chatbot doesn't yet know anything about our data because we're not passing our proprietary data in as context. So let's do that next. So next, we'll add a few files that define our RAG flow. Let's look at the graph. We still have a single node, but it's now a node of type Python, which means that it's going to run the code in our Python file. And we still have the same two inputs, but we added another couple of outputs for debugging purposes.
So our flow now has the RAG code. That means that the chatbot should now be able to answer questions about our outdoor equipment store, right?
Yeah, that's right. Let's test it like we did before by asking it for a 2% tent. Okay, that works. We would like to see a few more debugging details about our scenario. For that, we'll use our custom client-side code. Let's copy the code and let's run it. Let's ask the same question again. Which two-person tent do you recommend? We can now look at debugging information using the UI. It seems that the answer matches the data in our chunk. We can also go back to our data and find this file. Yep, here it is. So yes, the chatbot now knows about our data.
That's exciting. Can we look at the code in this new flow?
Sure. The Python node in our flow runs this rag.py file. And you can ignore this commented outline for now. We'll come back to it later. But here are the two main steps in our RAG code. The get context function searches our index for data that's relevant to our input question. And the RAG function queries the LLM using the user's question and the data returned from the previous step. The get context function takes the user's question, creates an embedding for it using an OpenAI embedding model, searches the vector index we created earlier for that vector, and returns the resulting document chunk. This pop parameter controls how many chunks we're returning, and as you can see, we're just returning one chunk. The RAG function constructs a message containing the chat history, a system prompt, and a user prompt. The system prompt can be found in this Ginger file, and it pulls in the document chunks retrieved in the get context function before. And the user prompt is just the user's question. This message is sent to the LLM, we get back an answer, and we return that answer to the user.
That makes sense. Can we play with that chatbot a little more?
Sure, what do you want to ask?
Can you please ask, which GPS devices would you recommend for backcountry navigation?
Okay, let's see if that matches up with our data. Okay, I think you've broken the chatbot. Yeah, it seems that our chatbot is making up information.
Maybe we can fix this by improving the prompt.
Yes, that's a good idea. Okay, it's my turn. Let's ask, do you have a lightweight tent? Looking at the context that gets passed, it seems that is a good answer. So it's working.
Okay, my turn now. Let's ask, how much does it weigh?
Okay, it says 4 pounds. Is that true? That's also a lie. Oh, looking at the context, it seems that the chatbot is confused about the product our question refers to.
Well, that may be because we're searching the vector index for an embedding for how much does it weigh. And without knowing what it refers to, the vector index doesn't return the right document chunks.
Yeah, I think you're right. We may be able to fix that.
Okay, this is kind of fun. I'll do one more. Let's ask, what other tents do you carry?
Okay, so let's look at the context. Okay, these are also made up.
This is probably because we're only including a single document chunk in our context. If we include more, then maybe the chatbot is able to learn about all the tents we carry.
Yes, that's possible. Clearly, our chatbot has a bunch of issues that we need to fix. But before we start experimenting with fixes for these, we need to set up an evaluation flow, which I'm going to copy paste into our project. This is the flow just like the RAG flow we saw, but instead of running RAG, it evaluates a chatbot answer based on several metrics.
And how exactly are these evaluations done?
At the heart of it is just a Ginger template. We give it the user input and the output that we got from the RAG. We send that to a GPT-4 model, and then the model evaluates the quality of the answers we got. For example, one of the metrics we use is groundedness. And to evaluate it, we use this prompt template here. You can see that the prompt says you need to decide whether the answer is entailed by the context and conversation history. And then we ask it to give a score between 1 and 5. But you can do whatever you want in your evaluation flows. It's just Python code.
I see, that's useful. What other metrics do you have?
We're testing for coherence, fluency, groundedness, and relevance in our scenario. And because this is just a normal flow, we could run it as usual. But this evaluation flow is also connected to our custom debugging UI, so we'll run it that way. Let's ask some of our questions again. Let's ask, which two-person tent do you recommend? That gets pretty good results. Now let's ask, how much does it weigh? And this time the results aren't so good.
Okay, so we can evaluate the last answer of a conversation using this evaluation flow. But how can we use this as part of a more generic process of testing and improving our app?
Well, for that, we can't rely on an individual example. We need to have an easy way to test with many examples. So I'm going to copy a file with a list of questions to our data folder, which we can use then to do a batch evaluation. You can see that I have here several single questions and also a few back and forth conversations with the chatbot. I also added this script that helps me run all my questions through my RAG flow and then runs the results through the eval flow. So let's do that. It will take a few minutes, so we're going to skip ahead in the video. Let's look at the evaluation flow outputs in the cloud. You can see here that for each input, we have an output with well-defined ratings for all our metrics: coherence, fluency, groundedness, and relevance. Let's see what we can learn from a result that isn't so good. It seems that number 11 didn't do well on groundedness. That's because the user asked for a GPS device, which the store doesn't carry. But the chatbot recommends something anyway.
Is there a way to see an aggregate of the metrics for all data in this evaluation run?
Sure, we can look at the metrics tab for that. Okay, now we have a baseline for our metrics, and we're ready to start experimenting with our code. What should we change first?
Well, I think we could do a better job with a RAG system prompt. It seems that the chatbot tends to make up information about products that just don't exist. So how about we add better instructions in the prompt saying that the answer needs to be based on the context that was provided?
Yeah, we can do that. How about this? Please write a reply to the customer based on the content provided. Do not include any additional information, blah, 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 and then some more restrictive language.
That looks good.
Okay. We'll rerun our two flows in the cloud, and we can look at the evaluation results in the cloud. Let's see if the metrics improved. It seems like groundedness and relevance improved, but fluency and coherence got a bit worse. So let's look at the outputs and see what we can learn from that. Okay, question number 11 seems to be better now. It now knows that there are no GPS devices. Let's see what other issues we have. It seems that we have an issue with question number 14. We're asking for the 3 best-selling tents, but the chatbot isn't giving us any helpful information. Any ideas to fix that one?
Well, I wonder if this is happening because we're only passing a single document chunk in the prompt. So the chatbot has no way of knowing about more than one tent. We could increase the number of chunks to fix that. And to avoid hitting token limits, we could reduce the number of characters in each chunk at the same time.
Okay, let's do that. We go into the init search file, change our chunk size to 1000, and rebuild our index. Now we have 261 chunks. Next, we go to the reg.py file and change the number of chunks passed in the prompt to 6. We can now rerun our flows. And we can check the results. All our metrics went up, which is great. Let's look at the outputs page. And it seems that number 14 gets better scores now, and it's showing us 3 different tents from our product lineup. So let's see what other issues we have. Number 16 isn't doing so well on relevance and groundedness. The model recommended a tent in the first reply, and then when asked about how much it weighs, it didn't seem to know about it anymore. Do you have any ideas to fix this issue?
Well, this is a trickier one. We're adding each document chunk to the vector index, and then we're searching that index using the user's question. But this question refers to it and gives no information about what it is. So I suggest that we look at the chat history and summarize the user intent. So instead of searching our index for how much does it weigh, we really search for how much does the sky view 2-person tent weigh?
Okay, we can do that. Let's go to the reg.py file and call the summarize user intent function, which makes an extra LLM call that summarizes what the user is really looking for based on the history of the conversation. We can take a look at the user intent prompt in this template file. As you can see, it says, given the chat history and the user's query, infer the user's intent expressed in the last query by the user. So with those changes, let's run both flows in the cloud again. And let's look at the results. The overall results seem to have improved, with the exception of fluency, which regressed a little. If we look at the outputs page, question 16 seems much better now, and the reply is giving the user the correct weight of the tent. In fact, let's see the graph with the metrics results for all our experiments to really understand our progression here. As it shows, even though not all the metrics went up with every change, overall, I would say that we should keep all the changes we made. Don't you think?
Yeah, I would say so.
So we made several improvements to our code in this session, but we could just keep going. For example, we could experiment with the temperature and topic parameters in the LLM calls, and we could change the overlap of the document chunks.
Yeah, those are good ideas. We could also play more with summarization of chat history. And we could introduce a function that allows the model to query the product catalog to better answer overview questions.
Yes, those are all good ideas. If we had more time, we could keep going.
For sure. This was a super cool demo, Daniel, and I think people will find it useful. So what is the main takeaway from the demo?
So the key point is that it's important to be able to systematically test out generative AI apps during the experimentation phase. If we're able to track our results with well-defined metrics, we can easily tell which of our experiments worked and which ones didn't. And ultimately, this will result in a better app.
I couldn't agree more. I think there's just so many decisions that go into creating one of these applications. It's really good to have good tools that can tell us which ones pay off and which ones don't, basically.
Totally.
All right. Thank you so much, Daniel, for the demo. And thank you, everyone, for watching. We hope you enjoyed it, and we'll see you next time. Bye.
Bye-bye.